Yeah, hi everyone, and welcome to this WebSphere virtual event. My name is Lohit Ashwa. I'm the SIBus product architect working for the India Software Labs. And in my current role, I'm responsible for interacting with various customers, stack products, account reps, and then working out on all the requirements and features that are needed for the service integration bus. And in today's session, we are going to talk about messaging with the application server. So why are we here? As you know, IBM has two different messaging systems, one WebSphere MQ and the other the service integration bus that comes as a default messaging system for the application server. So for the customers who wants to use messaging along with the application server, so need to understand what are the various options that are available within VAS. The second is when the customers or other users have some questions asking about, can we use SIBus as a full-fledged messaging system, or it should be always be used in conjunction with the WebSphere MQ? Or for those users or customers where they believe that they are using WebSphere MQ for their messaging backbone, and is that the only right way in which I should access it from my application server, or tend to use SIBus or along with SIBus? So in this session, we are going to talk about some of the options that we have on enabling your applications to interact with the backend messaging systems. So let's quickly touch upon some of the basics. So what's messaging in a slide? So as we know, the application server is a full-fledged J2EE compliant application server. And what it means is that the support of asynchronous messaging, that's Java messaging service, is mandatory for the application server. And application server, the WebSphere application server, supports the complete JMS 1.1 specifications. What this JMS means is that it allows your applications to be loosely coupled without having to be bothered about where the application is running or whether the application is running, but directly send and receive messages without knowing each other. And moreover, it provides you with a standardized programming interface, so that all vendors can implement the same thing, and applications running across vendors can send and receive using this particular JMS standard. And one thing that we need to remember is JMS is not a transport protocol, so we do not bind anything specifically on the JMS standards. It's only from an application layer perspective. And JMS supports two types of messaging paradigms. One is a point-to-point, where Q is the focal point for exchanging of messages. And the second is a PubSub, which uses topics as a reference point for exchanging of the messages. So, WebSphere application server, as such, provides first-class support for both the messaging providers that IBM has. The first one is, of course, the embedded messaging provider or the default messaging provider, or what we call as a service integration bus. And the second is the WebSphere MQ, which can be used as an external messaging provider. Let's try to understand or quickly glance about WebSphere MQ in a slide. I know it's fairly difficult to talk about MQ in a slide. So what we can see over here is WebSphere MQ has been the IBM's flagship product in the messaging middleware systems. In fact, MQ is the backbone for the entire messaging and connectivity for the SOA in itself. So from a WebSphere MQ perspective, the Queue Manager is the one that provides the entire runtime. So a Queue Manager is responsible for providing all the resources like the queues, topics, channels, storing the messages, providing the transactional capabilities, security. So all these things are something that are managed by the Queue Manager, which is the heart of the WebSphere MQ in itself. And Queue Managers can connect to each other over a network, probably within a cluster, so that you can get your high availability and scalability options. WebSphere MQ is a pretty distributed messaging system. What I mean to say is that it supports a wide range of programming languages, runs on all platforms, and it doesn't have any constraint over the language that the application has to use. And JMS is, of course, one of the things. From an application server perspective, applications have to use JMS in order to interact with the backend messaging system. And WebSphere MQ provides a first-class JMS 1.1 support for Java applications to send and receive messages either running within the application server environment or running outside the application server environment. So that's the power of WebSphere MQ. Talking about Service Integration Bus, or I can call it as an SI bus. Now, SI bus is a native component of WAS. Now, what I mean to say is it is an embeddable component within the application server runtime. So when you install your application server, you have your messaging system already installed within that. And it is so tightly coupled with your runtime that it leverages on all the WAS runtime capabilities that it offers, something like the clustering capabilities, the high availability capabilities, the workload management, object management. So all this something that the SI bus implicitly leverages on from the WAS runtime. Now, one of the biggest advantage that the Service Integration Bus or the SI bus provides is the location transparency. Now, because SI bus is totally integrated into the WAS runtime, it takes care or it takes advantages of the various non-functional requirements that WAS offers. For example, we know that in a WAS network deployment edition, we have the concept of cells, and a cell can have multiple nodes, and each of the nodes can have multiple servers. Now, a bus scope or the Service Integration Bus scope is all across the cell. So when you define a bus, the scope of it is available all across the cell. So your application wanting to connect to a destination can run across any of the nodes, any of the servers, and it can send and receive the messages from the destination without knowing where exactly is this destination physically hosted. Now that's a primary advantage that SI bus has to deliver from a location transparency perspective. Now, what you can see on this particular slide is a simple representation on how it works. So we see a bus over there, which is a logical representation. So it doesn't have any physical runtime as such. So we term it as a logical runtime. And the destination over there resides on the bus, not confined to a particular server. So any application can access all or any of the resources on the bus regardless of its location. So as I just mentioned, so bus is a logical entity that contains the destinations, and all your messaging applications connect to the bus to access the destination. So your application need not have to know anything apart from the destination name and the bus in itself, right? The underlying resolving of your application connecting to a particular destination and physically getting the message is all something that happens under the covers. From a physical runtime perspective, we have something called as a messaging engine, which is the heart of the SI bus. Now, messaging engine is the one that provides us with all the runtime capabilities for the messaging applications to connect and exchange the data. Now, as such, the messaging engine is realized whenever I had a server as a bus member, or I can add a cluster as a bus member, or I can add WebSphere MQ in itself as a bus member. So whenever I add a bus member onto a bus, I get a physical runtime, and which I term it as a messaging engine, which will then manage all the runtime and the persistent state of the messages and the resources that are defined on the bus in itself. So these messaging applications then transparently connect to a messaging engine, and all the messaging activities are then routed among each of these messaging engines transparently to the application in itself. And hence, we get the location transparency from a SI-bus perspective. So the slide SI-bus runtime model shows you a simple view on how a messaging engine resides within an application server. And this is a standalone application server that's been added as a bus member. Right, so applications directly connect to the messaging engine through the application server and then send and receive the messages. So what are the options that we have? Now, the moment we talk about having two different messaging systems, I'm sure we'll have multiple options that enables us to connect to the backend messaging systems. So let's look at the 4 key options that we have for the messaging within WAS. So the 4 key options that we can see here is first is to use the service integration bus as the JMS provider in WAS. The second, to use WebSphere MQ as a JMS provider in WAS. The third being, we will use service integration bus in the WAS and then connect the messaging system to the backend WebSphere MQ. And the fourth option is, we'll use SI-bus for all intra-WAS messaging and use WebSphere MQ for inter-system messaging. Let's look at what each one of these options means to us. So on this slide, what we can see is that option 1, the SI-bus being used as a default messaging system for your WAS applications. So on this slide, we can see that each of the application server can have a messaging engine, or they don't have to have a messaging engine, but can connect directly to an application server that hosts the messaging engine. And in this diagram, what we can see is the SI-bus is being used as a default messaging system or a full-fledged messaging system for the applications running within WAS. Option 2 is to use WebSphere MQ as the JMS provider in WAS. So what you can see over here is we don't have any reference of SI-bus at all. So you can directly configure your WebSphere MQ to be the messaging provider, and you configure MQ to be your external messaging provider for all your applications that are running within your application server environment to send and receive messages from the WebSphere MQ backbone. So the third option is pretty interesting. So what we are seeing over here in this slide is we are going to use SI-bus for the WAS application messaging and then connect SI-bus to the WebSphere MQ backbone. So what it means is the applications that are running within the application server is totally transparent about the existence of WebSphere MQ. So they can still leverage on all the non-functional requirement that the WAS provides, like the location transparency or the high availability, scalability, workload management. So all these things can, the applications can leverage on that and then leave the rest of the message transferring to the SI-bus infrastructure to send the messages to the WebSphere MQ. So what it means is it makes the applications running within the WAS to still look forward for only one messaging resources, that is SI-bus, and the underlying transfer of messages is totally transparent from the application perspective. And the last option that we have is to have an intra and an inter messaging system. So if I have an option to segregate the way my messaging works, so I try to keep SI-bus for all my WAS-based applications. For instance, if my producer as well as my consumer both are running within the application server, it definitely makes sense for me to use SI-bus without even going to WebSphere MQ. A typical example is an MDB that runs within, or the message-driven bean that runs within the application server runtime. But in situation where you have a cross-messaging requirement, so that's when I go for using both together for SI-bus for intra-WAS and WebSphere MQ for inter-WAS WAS messaging. And whenever it comes for a discussion related to choosing WebSphere MQ versus SI-bus, even though the intent of this particular session is not to talk about the pros and cons, but I'll put one slide that gives you an immediate feel about when to use a service integration bus and when I can use a WebSphere MQ. Very clearly, service integration bus and WebSphere MQ are not competitors to each other, but rather we have positioned it pretty strategically based on the customer needs and the demands. So what you can see on your left-hand side talks about some of the cool features of the service integration bus, which is fully integrated with the WAS runtime and can be configured within the console in itself. Whereas WebSphere MQ has its own runtime, own admin domain, and the Explorer interface. So whenever we want to use a WAS and MQ, so both of them will be two different runtimes. SIBus has been with WAS since 2005, and we have a growing customer base. Of course, it has got a limited tooling support as of now, but when I talk about WebSphere MQ, it's been there with us from more than 2 decades, and it has a huge install base and, of course, a widespread of tooling support. From an SIBus perspective, strategically, we target the stack products that are built over WAS, primarily the WESB or the WPS or the business fabrics or any of those Tivoli products that are built on the WAS runtime. They leverage SIBus as their primary messaging system. Whereas WebSphere MQ, we position it from a message broker perspective or from an FTE perspective, where MQ directly integrates into MB and FTE. Of course, there is no difference in the kind of security, the robustness, and the messaging paradigms that we support from the point-to-point and the PubSub. SIBus is primarily JMS oriented, but WebSphere MQ, as I told, is a pretty ubiquitous messaging system that it caters for anything and everything. SIBus is primarily optimized for the WAS-based messaging performance so that we can take advantage of all the WAS runtime capabilities. Whereas WebSphere MQ is definitely optimized for heterogeneous messaging performance, where it gives you an edge because it directly leverages on the underlying platform that it is running on. But the key thing to remember is not to forget the skills that our teams have and the existing messaging infrastructure already is there in our environment. So that should give you a glimpse about the various messaging options that you have with WebSphere Application Server, and also some of the key differences between the SIBus and the WebSphere MQ. Thank you.